Hello, today we're going to be looking at angles and arcs around circles. There are several different types of angles within and around circles, but we're going to focus today just on central angles. Central angles have a vertex that's at the center of the circle, and the sides of the angle are radii of the circle. In this first picture here, you can see a central angle called angle ACB. It has its vertex here at the center of the circle C, and its two legs are the radii AC and BC. I think you all know, but in case you don't, the sum of all of the central angles inside of a circle is 360 degrees. So if I added up every angle all the way around the circle, it will always add to 360. Okay, the other part of today's lesson is on arcs. An arc is a part of the actual circle itself. So that means part of the outside of the circle. Arcs are measured two different ways. One is according to its number of degrees, and then the other is its length, which we'll get to later on. But arcs are also categorized according to their measure, their number of degrees. We have major arcs, minor arcs, and semicircles. So a minor arc is an arc whose measure is less than 180 degrees. An arc that takes up less than half of the circle. You can see here, this minor arc measures 100 degrees, the same as its central angle. When we name a minor arc, we name it according to its two endpoints. So here the arc starts at A, goes across the circle clockwise to point B. So the name of this arc is arc AB with this symbol, this kind of curve symbol above those two letters. We also have major arcs. Major arcs take up more than half of the circle, but less than the full circle. So here we have a major arc, D, E, F, and that indicates this portion of the circle. This arc can start at point D, pass through point E, and end at point F. Major arcs are always named with three letters. So I called this one arc DEF. Starting at D, name any letter it passes through, and then the ending point. This could also be called arc FED. It does not matter which direction you go in. And again, this is a major arc. Its measure is bigger than half of the circle. And then the last type of arc you should be familiar with already is a semicircle. A semicircle is exactly half of a circle. Here I've highlighted one of the semicircles here. And this gets named the same way that a major arc gets named. So that we know which half of the circle that we're focusing on, we give a starting point. So here let's say G, a point that we pass through, and then the ending point. So arc GIH or GJIH indicates the right half of the circle, whereas if I wanted to talk about the left semicircle, that would be arc GJH. Okay, down at the bottom here, let's take a look at the first example. So here we're given a circle and it says find each measure. And each of the questions is for one of the central angles inside of the circle. So one of the things to note about this picture is, first of all, we have all of the central angles here. Only one of them is given an actual measure in degrees. That angle MCN is 60 degrees. It creates a linear pair with angle NCL. Together, these two angles create a linear pair or take half of the circle. So if angle MCN is 60 degrees and I subtract that from 180, I can figure out that angle NCL is 120 degrees. So question number 1, angle NCL should be 120. In order to figure out the other angles that are asked for, we're going to have to solve for x. When I look at the left half of this circle, on the left semicircle, I have 2 angles here, each labeled with algebraic expressions. Those 2 angles also form a linear pair, and therefore we can add them together, set them equal to 180. So if I write x minus 1 plus 3x plus 5 equals 180, I can solve for x. And we should get that x is 44. Once I know that x is 44, I'm going to plug that back into our 2 algebraic expressions. So angle RCM, which was x minus 1, will now be 44 minus 1, or 43 degrees. Angle RCL, which is 3x plus 5, 3 times 44 plus 5 makes this angle 137 degrees. So to answer our questions, the measure of angle RCL we just said is 137. Angle RCM we labeled as 43 degrees. And angle RCN is a combination of 2 of the angles that we labeled. So RCN is this larger angle. So if I add up 43 degrees and 60 degrees, I find that its measure is 103 degrees. Okay, when you flip over to the back of the notes, the next question is now asking about the measures of an arc. So I said this very briefly, but an arc's measure in degrees is the same as its central angle, corresponding central angle. So when I take a look at this picture, it says in circle A, the measure of angle EAD is 42 degrees. That means angle BAC must also be 42 degrees, since those are vertical angles. And then the obtuse angles are going to be the same as well. They will each be 138 degrees. Once I know all the central angles in the picture, I can find their corresponding arcs. So question number 5 asks for the measure of arc BC. So arc BC is going to have the same length as its corresponding central angle. So if angle BAC was 42 degrees, arc BC is also going to be 42 degrees. Question number 6 asks for the measure of arc CBE. So that means I start at C, pass through B, end at E. We can see that arc is a perfect semicircle, so it must be 180 degrees. In number 7, we're looking for the measure of arc EDB. Start at E, pass through D, end at B. In order to figure out the measure of this major arc, we can either add up all 3 central angles, 42 degrees, 138 degrees, and 42 degrees, or we can also do 360 minus the section that we don't want. So 360 minus 138. Either way, we find that the measure of this major arc, EDB, is 222 degrees. And then question number 8 wants the measure of arc CD. So start at C, end at D. I know they're talking about the minor arc because it's only 2 letters in the name. So arc CD, the same as its central angle, should be 138 degrees. In question number 9, a circle gets broken into 3 central angles that have measures in a ratio of 3 to 5 to 10. Find the measure of each of those angles. So remember when we did ratio questions about perimeters or angles of triangles, we're going to represent the measures of each of those angles as 3x, 5x, and 10x. Since they are the 3 central angles of a circle, we know that they have to add up to 360 degrees. So 18x should equal 360, which makes x 20. To find the measure of each of those 3 angles, we'll plug back in. So 3x, or 3 times 20, makes the smallest angle 60 degrees. 5x, or 5 times 20, makes the medium-sized angle 100 degrees. And the angle labeled 10x should be 200 degrees. Note that all 3 angles together add up to 360, which is a good sign because it should fill the entire circle. So as I mentioned, there are 2 different ways to measure arcs. One is its measure in degrees, and then the second is its length. Arc length is the distance around a circle, but not the entire way around, just the portion that's contained by your arc. So imagine if you were going to walk around a circular track, but you stop halfway or you stop 3/4 of the way. We're figuring out how far you would walk. Arc length has a formula. L, which represents its length, is A over 360 times C. A represents the corresponding central angle measure, or the number of degrees for that arc, out of 360, the full circle, times capital C, which is our circumference. So it's the measure of the arc out of 360 times circumference. In question number 10, it says points T and R lie on circle W. So here's circle W, point T and point R lie somewhere on the circle, so that the length of WR is 12 and the measure of angle TWR is 60 degrees. Find the length of arc TR. So we need to figure out how long this portion of the circle is. So let's use our formula for arc length. Arc length is the measure of the arc. So our arc, same as its central angle, is 60 degrees out of the full 360 of the circle times circumference. So times 2 times pi times the radius, which is 12. When you type all of this into your calculator, you should get that the length of our TR is 12.6, and this one is just in units. Notice how in this formula, we're essentially taking a fraction of the circle, a fraction of the circumference. We want only a part of the circle, 60 degrees out of the full 360, times the circumference. So it's a fraction of the way around the circle, therefore a fraction of its length or a fraction of its circumference. And the last 2 questions are to practice arc length as well. In question number 11 and 12, it says the diameter of the circle is 32 inches. Find the length of each arc for the given angle measure. So in question number 11, we're asked to figure out the length of arc DE. So here we want this minor arc because it has 2 letters, so arc DE. If the measure of angle DCE is 100 degrees. A central angle and the arc have the same measure. So I plug into my formula for length. 100 degrees out of 360 times circumference. This time I have the diameter, so let's just do times pi times diameter, 32. And when you put this one into your calculator, you should get about 27.9. And this one is in inches. In our last question, we're asked to find the measure of arc HDF. So arc HDF is going to be a major arc, bigger than 180 degrees. So if I start at point H, go around the circle, I pass through point D, and then stop down here at point F. So I'm looking for the measure of this large arc. If the measure of angle HCF, so angle HCF is here, is 125 degrees. Although we plugged our given angle measure directly into our formula, we can't do that in this question. If we want the measure of this big major arc, we need to know the number of degrees for this big major arc. So here I have to first take 360, subtract off the 125 degrees that were given to me to figure out how big the rest of the circle is. So the remainder of the circle is 245 degrees. That's the measure of arc, HDF. And now that I know its measure, I can plug into the formula for length. So I have 245 out of 360 times circumference, so times pi times our diameter is still 32. And when that one goes into the calculator, the length of this larger arc should be 68.4 inches. Please make sure you complete the worksheet for homework tonight. Have a great day.